Hey folks, and welcome to the session. I'm very excited to be introducing Android today using the Kotlin language. I've been writing Android apps for the last 8 years, and it's been definitely a rewarding journey so far. As I'm sure you know, Android has a strong presence in today's digital world, and there's no better time to get into it. Let me start by introducing myself. I'm Adam. I've been writing Android code since 2012, and I'm a Google certified Android engineer. I've built production apps of all sizes and worked with many international clients. And in my free time, I like to build automation machines that solve everyday problems, like hardware and software coming together to solve everyday problems. In fact, the reason I became an Android developer was I was tuning my car back in 2012, I think. Yeah, 2012. And I had a 3 Series BMW, and I attached a module that soups up the engine. And I wanted a way to remotely control the settings without having to pop the hood every time. I had an Android phone lying around, so I figured the best way to do that would be to just build an app that interfaces with the module using Bluetooth through an Arduino controller, if you're familiar with that. But after completing the project, I basically got hooked, and I took on more Android projects up until today, going 8 years strong. So I know a lot of you have iPhones, but actually Android is by far the leading mobile OS worldwide today. The main reason for that is that Android is open source and it's compatible with countless types of devices beyond just phones and tablets. Demand for Android developers has been basically surging nonstop since Google bought it in 2005. In fact, if we do a quick Google search, I'm going to do that right now, of Android jobs Montreal, you guys can see there is like unending opportunity. So for sure, if you get into Android now, you're never going to be out of work. And I'm sure you're also going to be working on a lot of cool projects. So you probably get to pick even which project that interests you to work on. As I mentioned, Android runs on more than just phones and tablets. I'm sure you've heard of Android TVs, smartwatches, but Android can actually run on any kind of device. It was originally meant to run on digital cameras, but given its power and open source nature, it became not only the dominant mobile OS today, but it's popped up in many different industries as well. So cars, exercise gear, home security, appliances, game consoles, karaoke machines. I've even seen an Android mirror once. So learning Android, you'll be able to develop apps for all these devices, and I'm sure you're going to be building some pretty neat stuff. So let's start from the beginning. Let's get into a little bit of history behind Android. So it was founded by 4 engineers. I have their picture right here. And they built the first version back in 2003. As I mentioned, it was actually meant to be an OS that runs on digital cameras. A few months into its development, though, they realized the potential behind it, and there was an explosion in the smartphone industry. So they shifted focus to make it a mobile OS. It quickly became popular with vendors due to its open source nature. And of course, Google took notice of that, and they bought it back in 2005, just 2 years after it was on the market. And everything kind of changed from that point on. As mentioned, Java started out with Java, or maybe I didn't mention that yet. Actually, we're going to mention that. Let's mention it now. So Android started out with Java as the main language, but as more modern languages started popping up across the industry, Google announced that Kotlin, which is the language that we're going to be talking about today, would become an officially supported language in the Android OS. So Kotlin actually still runs on a JVM, a Java virtual machine. So it's fully backwards compatible with Java. And if you're familiar with Java, you will feel right at home. You'll find that Kotlin is just a layer on top of it to provide some pretty neat utility and simplify your experience as an Android developer. Kotlin has actually been around for way longer than that, though. It was unveiled by JetBrains. That's the same company behind Android Studio. We're going to talk about that in a little bit. And they unveiled it back in 2011. The name Kotlin actually comes from the name of an island near St. Petersburg, just like Java, which was named after an island also off of Indonesia. I totally thought that Java is like coffee. Java is another way to say coffee, but it's actually the name of an island. And the reason they developed Kotlin, as one of the main engineers behind it, Dmitry Jemerov, put it, is that most languages didn't have the features they were looking for, so they basically built one from scratch. They built one themselves, and the version 1.0 was released in February 2016, and Google announced first-class support for it just 1 year later. Here's a graph from Indeed.com. Actually, this graph is a few years old. Nonetheless, it shows employer interest in mobile development skills. So keep in mind, this is a few years old. It's very likely that Kotlin is now #1 just based on the intense momentum Kotlin has been building over the years. Once you pick up Kotlin, you'll have an abundance of cool projects that you can work on, and your skill set will be very much in demand by almost all companies in the digital space. All right, let's talk a little bit about what Kotlin adds to Java that's going to make your life easier as a developer. So first off, as we talked about, Kotlin is completely interoperable with Java. Ultimately, Kotlin runs on a JVM. So under the hood, all the Kotlin code gets converted into Java code. This means that you can add Kotlin to existing Java projects, but you can also do the opposite. You can add Java into existing Kotlin projects, and it'll work just fine. So transitioning from Java should be fairly seamless. Kotlin is way more concise than Java. So I've been writing Java code for maybe 12 years before I moved on to Kotlin. And I love Java. I thought I never had any issue with Java, really. But when I started using Kotlin, I found that my life has become so much simpler. So what concise means is that you'll be basically able to build more sophisticated code and apps with less effort. We're going to go over some of the examples today, and you'll see some of the things that Kotlin adds on top of Java. It basically adds some shortcuts and abstractions so your code is more easily readable, maintainable, and extendable. Next up is null safety. So this is a big one. Null, as I'm sure most of you know, well, I'll define it first. So null, essentially when you say you define a variable when you don't have to give it a value right away because maybe the data for it wasn't ready yet. And null was actually invented by an engineer named Tony Hoare in 1965. So the concept of having a variable that's not assigned to anything is actually invented into the language 4 years ago. And at the time it was invented, it kind of made sense to build it into programming languages, simply because it was easier to make it that way. The problem is humans make mistakes. We forget, especially when writing complex programs. There will be cases when a program tries to access a variable that had not been assigned a value yet, and basically that will lead to a crash. This is no light matter. To quote Tony Hoare, the same guy who invented null, the null reference, null references have led to innumerable errors, vulnerabilities, and system crashes, which have probably caused $1 billion of pain and damages in the last 40 years. He actually apologized for inventing it in a software conference in 2009. So lucky for us, Kotlin by default does not allow you to set a reference to null unless you explicitly override that behavior. As we said, Kotlin's code is more concise. It goes without saying that concise equals compact, also equals clear code. And implicitly, that means that it's safer code. Being more compact, it allows for fewer errors. So I should mention that it is by design that Kotlin prevents common programming mistakes. This translates to fewer crashes, a reduced number of system failures. But what do I mean by preventing mistakes by design or from design? Well, what I mean is developers get encouraged by the compiler to consider potential issues in their code. And this is presented in early stages of app development. So the compiler will tell you if there's an issue and will actually stop you from continuing your build process so that if there's an issue, you can catch it while you're writing the code instead of discovering it after you've shipped your app and a lot of people are using it. Of course, that doesn't lead to a very good experience. So Kotlin allows developers to be cautious and to write more robust and stable code in production. Adding a good compiler has been one of Kotlin's development team's main goals when they created the language. It comes with a smarter and safer compiler than Java, as we touched on a little bit. And here are some important aspects of the compiler in Kotlin. So it detects errors at compile time. We already covered that. It does so at compile time, not at runtime, leveraging the fail fast principle. And that basically means you want to fail during development. You don't really want to fail after you've finished development and if you've shipped your app, and to kind of discover it later where it'd be a really expensive mistake. It performs a lot of checks and it reduces runtime errors and the number of bugs in the code. Kotlin is a statically typed language, which is very easy to read and write. You would need much simpler and shorter code than when using Java for the same problem. As this makes the language more human readable, it becomes easier to debug as well. So Kotlin's code is much smaller and it streamlines the programming process in comparison to Java. This is mostly because of Kotlin's slick IDE. So IDE is like integrated development environment. And of course, Android Studio is kind of the main perfect tool to be developing Android apps using Kotlin. So you will basically have, you're going to have all these very cool tools and also very cautious compiler. And the code is very concise. So whenever you're writing the code, especially when you're writing complex applications, you won't have to tear your hair out. Another key advantage of Kotlin over Java is that it's built with productivity in mind, with developer productivity in mind. And it goes without saying that enhanced productivity goes kind of back to back with concise code. So you're writing concise code. It's got intuitive syntax, and it's overall a clean language. We're actually going to build a full application in the next session, so we can get kind of firsthand experience at what it's like to be using Kotlin to be building Android apps. It'll take you less time to write new code in Kotlin, to deploy it, and to maintain it at scale than if you were to start out with Java. And there's more to boosting developer productivity in Kotlin than just that it's concise and clear. The language has been equipped with lots of powerful features that speed up everyday development tasks, such as, we're going to talk about 3 of them today. We're going to talk about object declarations, parameter values, and extension functions. There's actually more than that, of course. There's way more than that. I just picked these 3. I think they're simple ideas that we can kind of go over. Pretty sure a lot of you are familiar with some of the things we're going to talk about when going over these three ideas or 3 concepts. So, quick show of hands. Who here is familiar with the singleton pattern? And let me switch to Zoom just to see if there's any.
You can like react yes with the yes.
Can't really see it, but I guess it's because I'm sharing my screen. Cool. At least one person said yes. I'm gonna go with that. Object declaration is basically the same as the singleton pattern. This is so we have here an example of object declaration, and let's say we want to make a single and only instance of a class. So basically, we want to follow the singleton pattern. We can use object declarations such as here. We're creating a test class, and whenever we call that test class in our code, so we don't have to instantiate it or create a new instance of it. It'll always be just that single instance we defined. This is way simpler than having to create the singleton pattern ourselves. This is actually built right into Kotlin. And this is just an example of some of the tools that are provided to you out of the box. So you can kind of mix and match. You can use the tools in your tool belt to focus on the business of your app, the business logic of your app, rather than having to reinvent the wheel, rebuild some of the patterns that you've probably done a million times before. You can definitely save time just by leveraging the tools that are offered to you by Kotlin, such as object declaration.
Adam, sorry to cut you off. The screen sharing is a bit unclear, so it's kind of hard to read the code.
Gotcha. Okay, let me go back to that one and see if I can zoom in. Just give me a second.
No problem.
All right, so now I'm back to the previous slide. Let's see. No, that does not zoom in. Let's see if I can. I think yeah, it doesn't work. Let me see if I can do it from my streaming software.
Okay.
Oh, I found the button.
Yeah.
Cool.
It's so much better. Thank
No
you.
worries. Cool. So I'm just going to go over that slide one more time. So yeah, so this is basically, sorry, I zoomed in again by accident. Yeah, so as I mentioned, this is an example of object declaration, and we're creating a test class, and this is the syntax of creating a test class. And whenever we create a test class in this syntax, or any class really in this syntax, if we use the word object, the keyword object, Kotlin knows that we just want a single instance of this object. So if you use it within your code, you essentially will only have that one test object, one instance of it, and you don't have to write this singleton pattern, from the ground up. If it's not super clear, I'm going to make these slides available after. So definitely, I think this is the least clear one because there was kind of a little bit of, a lot of code to fit into one page. But I think the next slides are going to be fine. But nevertheless, you should be able to access this later and just to kind of go over the code in on your computer. Just gonna zoom back to normal. All right, so the second point that we mentioned was parameter values. So here's an example of parameter values. Basically, with parameter values, we can provide a default value for the parameters that we're passing into our functions. And in this case, we provided a default value of a to the variable letter and a default value of 15 to the number variable. This means that we can call this function without passing in any parameters, and Kotlin will know to use the default values of a and 15 automatically. So basically, you can have fallback values, and of course you can override them. So if you specify them, you can override that behavior, but it's also worth mentioning that you can name your variables whenever you're declaring them. So I didn't actually write an example of this. It's fairly simple, but you can, let's say you have two integers. Instead of relying on the order of, the integers, which might be a little bit confusing, you can say, let's say our two parameters are int1 and int2. So in your function calling, you can just say int1 equals, whatever, let's say 15, and then int2 equals maybe 21. So that also, makes things more clear and less error prone. Then we have extension functions. So extension functions basically allow us to add a function to an existing class without modifying that class. In this case, we're going to be adding an extension function called remove first last char. So we're basically removing the first and last character. Lila, can you see the code, or do you want me to zoom in again?
No, I think it's good. It's good for me.
Okay, great. So as I mentioned, extension functions allow us to add a function to an existing class without having to dig into the code of that class or modify that class. So without going into the string class, here we're able to extend that class and kind of write an extra function to it. And this way, we can simply call this extension function that we created, which is remove first last char or character, on any string. So whenever you have a string variable, you have an instance of a string, you can actually just call this new function on it, and Kotlin will apply your extension function to it. That's yet another cool shortcut to boost your productivity. As you might be getting familiar with so far, it's fairly similar to Java, but some things are just kind of moved around in a way that maybe in the beginning it will take a little bit of getting used to. But I assure you, after I switched to Kotlin, there is no going back. Like, I look at Java code now and it feels like ancient history. So once again, I definitely enjoyed it when I was working on it for 8 years. But over time, as I've became more familiar with Kotlin, it just feels more modern, more concise, and it does a lot of the heavy lifting for me. All right, let's talk about functional programming. So functional programming means that we can pass a function as a parameter. Think of it as like a variable that's set to a function, and you can pass it around. It's also known as lambdas. I personally struggled a little bit with functional programming in the beginning before Kotlin came along and made it super simple. Just the idea of passing a function into a function, which this is actually called higher order functions, simply because you're kind of going one dimension higher. But that idea to me, man, it took me the longest time to get it. But Kotlin is built in a way that makes writing functional code super simple. You can juggle with functional concepts in a more explicit and concise way. I have an example here on my screen of functional programming where we define a function and then we can basically pass it into another function. And as you can see, it's fairly easy to follow. It's not very complicated, and you can do some very complex things, but the code will still be readable. Not just by you, but also by the next person who might be reviewing your code or extending it. It's fairly straightforward to follow. Kotlin also does inlining. So this has to do also with functional programming. This is a performance improvement technique. That's what inlining is, which happens under the hood to improve performance. I have a definition of it here, so I'm just going to read it out. Inlining is an attempt to remove or reduce the runtime overhead of Lambda functions by moving or inlining the higher order function and its Lambda argument body to the call site. Wow, if that sounds confusing, don't worry about it. It's simply a way of reducing the processing that happens under the hood by moving around the code, so that the computer that's going to be running it, which in our case is going to be an Android phone with limited resources, it will run in a way that's as if you had written it sequentially without having to do any kind of fancy stuff. So that's a free performance boost that you get out of the box. It kind of rewrites your code in a way that's more performant. All right, now let's dig into some examples of Kotlin code. So what I'm going to do is I'm going to do some side-by-side comparison between Java and Kotlin to give you an idea of what Kotlin brings to the table. Let's start with something simple. This is the classic hello world. If I'm sure you're all familiar with it. It's like the first step to learning a language is to write your first hello world app. And if you're writing a Kotlin app, not necessarily an Android one, just you're writing Kotlin app, because Kotlin can run on any computer, really. It doesn't have to be an Android phone. Just like Java, you would need to provide an entry point, a main function. In this example, you can see that in the Kotlin version, we did not have to use the keyword public, as methods are public by default. So you don't have to specify that. You only have to specify it if it's private. Yet another shortcut. We also did not have to specify the return type, because Kotlin defaults to void. So if you don't specify return type, Kotlin assumes you're not going to be returning anything. And only if you specify a return type, that's when Kotlin will ask you for a return. And then, of course, it will give you a compilation error if you don't provide that return value. So one simple example of Kotlin conciseness is the printline method here, which ships with Kotlin. And it's simply, instead of having to go system.out.println, there's a shortcut for that. You can just say println, and there's like tons of those. So you're going to be kind of pleasantly surprised as you're getting familiar with the Kotlin language of just how much easier your life is going to be. And you're going to probably start to recognize that a lot of things in Java, while they may have been kind of the first way to, for the people who built Java, or the first iteration, over time, as people became more familiar with these languages, building abstractions on top of it to make our life easier just kind of became a no-brainer. All right, now let's move on to some variables. So in Java, the above code will compile with no errors. It's not going to complain. But what if you forget to set a value for W and then you try to access it later? Well, that would lead to the same dreaded null pointer exception. And if you don't catch it before shipping your app, obviously that can lead to a crash. Users will be frustrated. Nobody likes a crash. They're going to give you bad reviews, and all that can be avoided if you use Kotlin, because in Kotlin it's prevented from the get-go, as the compiler will stop you by giving you an error. Like, it's actually going to prevent building of your app. And that error will indicate that you either have to specify an initial value, so it's not going to be possible for it to be null, or if you explicitly want it to be null, then you have to actually you have to tell Kotlin that I need to use a null value here, or a nullable value here. And I think we're going to go over an example of that in the next slide. And of course, if you decide to declare a variable and have it be null, you take responsibility for handling the null reference yourself. So you're not really using, the leverage that's being provided to you by Kotlin. There are some cases, where you would want to do that, but from what I've seen, there should never be, like, you always find a way around having to kind of handle the null situation yourself. You just might need to dig in a little bit more into the Kotlin code and find a better way to do it. You'll also notice that the semicolon is gone. It took us 40 years to realize that we don't really need it, but I suppose better late than never. All right, here's another example of null safety. As we mentioned, in Java, we can just declare variables, and the compiler doesn't care if it's null from the get-go. It's going to allow you to do it. And in Kotlin, by default, variables are non-nullable. So if you declare a variable, and you must provide it with a value. And if we're absolutely sure that we want to set it to a null reference, as we just talked about, we can use the question mark operator. So just adding a question mark to the end of it, that means that this variable is nullable, and then Kotlin is going to leave you alone. It's not going to complain anymore. It's not going to try to protect you from making that mistake. And if you don't use it, the compiler will prevent you from using null by throwing an error right then and there, so that you can immediately recognize it and give it a proper value, or figure out a way or a strategy so that you can initialize it without having to run into a null issue. Now let's take a look at another example of how Kotlin simplifies code. Now let's say we want to get the length of a text. Let's also say that the text is a property of a class called department, which is, let's say we specified it to be nullable. So it can be null. And let's say that this department class is part of another class called Bob, which is also nullable. What we want to do, remember, is to get the length of a text that is part of department, that is part of Bob. So in Java, we would have to do a series of null checks. And finally, when we're sure that none of the above is null, we can finally call the method length. So that's like the safest way to do it. We will basically do a bunch of null checks. And when we're sure that there's no issue with nulls, then we can call the length method. And that would be the way to do it in Java. In Kotlin, we can just use the question mark operator. So the question mark operator, we mentioned that when you use it in declaration, it says that this variable can be nullable, but then you can also attach it to the variable after that to ask the question, is this thing that I'm about to call a method on, is it not null? Only in that case, perform the next bit. So if it is null, basically the rest is going to be ignored, and you're not going to get the dreaded null pointer exception. We can also provide a fallback. So what if it is null, but we don't just want to ignore, do nothing if it's null? Let's say we want to provide an alternative action if the reference turns out to be null. So rather than do nothing, we do that with what's called the Elvis operator. Because the reason it's called the Elvis operator is if you tilt your head horizontally, it kind of looks like Elvis Presley's hairstyle, the question mark and his eyes. So it took me a while to see that, but I think I see it now. We can also use if else in a variable or value definition. So this way you won't mix up the question mark operator, which in Kotlin is replaced with a classic if else. So because we've already used question mark, to do something else, we don't want to be using it in the same way that Java uses it, because that's going to be confusing. So the development team behind Kotlin decided, let's just use the familiar if else. So now let's say in this example we have text, and we only want to give it a value of x greater than 5 if x is greater than 5. Else we can just say that x is less than or equal to 5, and we're writing it using the all familiar if else syntax. Also, in Kotlin, we don't need the new keyword. Simply calling a class will automatically create a new instance of that class and call its constructor. So of course, when you call the class, within parentheses, if you don't provide anything, it's just going to call the no parameter constructor. But if you provide some values, it's obviously going to, fetch the relevant or the right constructor, but you didn't have to use the new keyword. So there's a lot of these omissions, like just that came from experience with working with Java. A lot of things have been kind of ripped out because they're very intuitive, like they don't need to be there. Maybe when designing the language, just to kind of help people understand what's going on. But as people became more and more familiar with the language, they realized a lot of this stuff can be just kind of can be deduced from the code. So a lot of useless keywords have been ripped out, and that's just another way that code is simplified using Kotlin. The final example of Kotlin that we're going to demo is another utility method built right into Kotlin for reading files. So I picked this one, but there's obviously, we covered print line as well, but there's so many other utility methods that are shipped out of the box with Kotlin. And I just picked this one as an example, but of course you can always go to the kotlinlang.org website, and you're going to find a ton of very cool utility methods. You don't have to import any extra libraries. You can start using them right away. As you can see in Java, we would have to, so let's say we want to read a file. In Java, we would first have to create a new file class. And of course, we have to, give that file class a path. Then we have to create a reader class. And finally, we have to create another class called buffered reader to finally be able to access the file. So it's a bunch of lines of code, but in Kotlin, we have some convenience extension functions built in that can do just that. And we already covered what extension functions are. They basically are functions that are added on top of existing classes without having to add those functions within those classes. So it's just another way of another utility, another way that Kotlin simplifies your life. You don't have to write so much boilerplate code. You can just focus on the logic of your application. All right, so now that we've covered the basics of Kotlin, we got our feet wet with Kotlin. Let's dive right into Android and see what makes up an Android application. So if you go to the Google developer, android.google.developer, or some variation of that, I'm sure if you Google it, you're going to find it. The first thing you're going to see is that Android applications consist of 4 main components. In my experience, you're not always going to use all 4. You're definitely going to be using activities, and you might be using services. You might be using broadcast receivers, and very rarely, in my experience, you're going to be using content providers, although they're all there and they're all there for you so that you can kind of structure your app in a way that it's based on different components that work very well together. So these are the main 4 components. We're going to go over each one of those and kind of talk a little bit about about what each one is designed for. Once again, they're activity, service, broadcast receiver, and content provider. An activity is equivalent to a screen. So inevitably, if you create an Android app that has any kind of user interface, you're definitely going to be creating an activity. It houses all the UI stuff, so that's user interface, but it also captures interactions from the user. So anything that you can see and you can interact with is going to live within your application. You can think of it as the main visual component of every Android screen. So before we move on from activities, it's also worth mentioning that an activity can be further broken down into what are called fragments. And so one activity can have just one fragment, but it can also have multiple fragments. Fragments allow us to split up the user interface into parts, which can be adapted to different screen sizes. Let's say, for example, you have an app and you have 2 versions of the same app, one of them that runs, or you want to have 2 versions of the user interface of that app, one of them to be launched whenever you're using a phone, and another version to be launched whenever you're using a tablet. So, excuse me. Fragments allow us to do just that. You can create a fragment, such as the one on the left, the one that has Hello World, and you can create another fragment, which is like the menu fragment, and only display on smaller devices the Hello World fragment, and then maybe a menu can be swiped, from the right or in the navigation drawer, or just some other way so you can save space on the screen. But if you have a full tablet, you have way more, way more size, way more canvas size, then you can add in the second fragment. And this is just a way to kind of modularize or create like sub parts of your activity. And each of those parts is modular on its own. So it can have its own data, it can have its own user interface. And it can, fragments can talk to each other. They can talk to the activity. There's really full flexibility in this whole process. And of course, we are going to be diving into an example of that likely next session. Today, we're just going to kind of go over all the concepts and kind of get familiar with Android Studio. But you will definitely be using activities, as I mentioned, and you will also definitely be using fragments to break down your activities so that it's kind of, there's a good separation that allows you to build your app in the same way that you're thinking about your app.
A quick question: would an app have one activity, or can it have multiple?
Generally, you would have multiple. So an activity is a screen, right? So for example, let's say the Facebook app, right? The first login screen, that would be an activity, and then perhaps you logged in already and you want to see your feed, that could be another activity. So it's really like a modular UI screen of your app.
Yeah, makes sense.
No
Okay,
worries.
thank you.
And for anybody else, by the way, feel free to just ask me to pause and ask a question about the slide, because you might forget about the question by the end of the slides. But so I'll be happy to pause and answer any questions. So next up is a service, and a service is another Android component which does not have a user interface. Its job is to house long tasks that are running in the background, and it can communicate with the activity that we just talked about to provide it with data that it needs. So maybe you can have a service that's talking to a backend, maybe fetching some data or saving something to your disk, or doing some kind of complicated task, maybe communicating with Bluetooth or Wi-Fi or something. You wouldn't really want to have that code in the activity. You just want the UI stuff, the UI interaction to live in the activity, and you want another component where you can put that stuff, and a service is the perfect tool, the perfect component to use that. If you're going to be doing any tasks which could have a delay, such as fetching data from a server, make sure to use a separate thread from within your service class. That's because a service class does not actually run on a separate thread. So, maybe not all of you are familiar with threading yet, but just to give you a very basic idea. So your processor has, modern processors can run multiple threads, and a thread is like one set of instructions that are kind of running in sequence. But if you want to have, parallel threads, or some, things that are running kind of at the same time without affecting each other, so you would have to create a separate thread. And a service class out of the box does not create a separate thread, even though it might seem that that's kind of the purpose of the class, so it should, but it doesn't. There is a special type of service called an intent service, which is kind of like another utility provided from Android, from the Android side, not so much from Kotlin, that actually does spawn its own thread, so you wouldn't have to do all that work yourself. But if you use a service, just like out of the box service, make sure that if you're going to be doing anything long running, to run that on a separate thread, so you don't interrupt the user interface. Because if it's long running and you try to run it on the user interface, so first off, the OS, Android OS, is going to not allow you to do that in runtime. It's going to tell you, hey, you're doing something that takes a long time. You're trying to run that on your user interface thread. That's going to create a bad experience. I'm not going to allow you to do that. So it's actually not going to allow you to do that. But there are ways to kind of force it to do that, and that's obviously going to lead to a laggy app. It's not really an experience that you want to ship for your users. Next up is a broadcast receiver. A broadcast receiver is yet another Android component which can listen to broadcasts or events that are either triggered from the Android system. For example, you might want to know when the charger is plugged in. So that would mean you would listen to the broadcast of that. Like, I don't know what the exact name is, but there's a broadcast for any system event, and you can be listening on it. So maybe you want to show a cool animation, or you want the phone to vibrate, or what if, for example, when the battery is low. So maybe you want to be notified when the battery is low, so you can do things like maybe reduce the rendering, or like make your app run a little bit slower so it doesn't use up too much processing power and drain whatever's left of the battery. You can do all those things by registering a broadcast receiver, which would listen to those specific broadcasts, so you can do some custom action in response. You can also, so these are the broadcasts sent by the system, so you can listen to them, but you can also build your own broadcast receiver and send to it your own broadcast. So you can kind of customize and leverage this tool to send your own broadcasts, which can be listened to by other applications or by other parts of the same application. For example, let's say we're building a chat app, which we're going to do. You might want to create a broadcast receiver which would receive a broadcast whenever a new message arrives, so you can do something. You can show it to the user, maybe vibrate the phone, maybe show them a notification. So essentially, you're just listening to certain events, and these events can either be triggered by the Android operating system, or they can also be triggered by you, by code that you've written yourself. Finally, a content provider. Now, for some reason, just from experience, content providers are, they're definitely there. There's definitely companies that, that use them in the perfect way. But it's a little bit more on the rare side, compared to an activity or a service. But it's definitely worth learning about. And it's actually very easy to learn what a content provider is, what it does. And of course, I encourage you to use it. Not that companies are not using them that much, that there's anything wrong with it. Absolutely not. But let's go ahead and define what a content provider is. A content provider manages access to a central repository of data. So that basically means, let's say you have a database. You have a database of users in your app, and you want to be able to access it easily from different parts of your app. Let's say, for example, those users are your contacts, and you want to be able to access your contacts from your messaging app so that you can message them. So one way to do that is to create a content provider, and content providers can provide content within your app, but it can also provide content outside of your app. So once again, if you want to expose that contact list outside of your application, then you can use a content provider, and there's a way to specify it. Essentially, what you do is you have to define, there's a variable called exported, just set it to true. It's going to export the content provider and make it visible to other apps so that they can communicate with your app. For example, if you've ever sent like something from WhatsApp to Facebook, for example, I don't know how they're doing it under the hood, but I would imagine a content provider is a perfect use case for that. Now, before digging into Android Studio, and looking at an example, like an example that ships with Android Studio, we should mention two more things. Actually, there's a third one that I think I forgot to mention in the slides, but we can definitely go over it when we launch Android Studio. But those two things are, the first one is Gradle. Gradle is a build system. So what that means is Gradle, it packages your app. It's like a system that packages your app into its final shippable form. An Android app is generally shipped as what's called an APK, like the extension of it is APK. So it basically puts all your code together, and it does all the tasks that you ask it to do after it puts it all together, and it makes your APK ready to be sent to the Play Store. So your app basically can be shipped, can live on the Play Store. People can download it, and they can also it can also allow you to do all kinds of cool things. So, for example, let's say you want to have different versions of your app. Let's say you want to have a free version and a paid version, like a premium version. So that's like a freemium model. Then you can specify in Gradle, all right, so in the free version, I want you to use these files. In the paid version, let's use some of these files, but let's also add to them, a bunch of other files. So Gradle allows you to do that in a very simple way, in a way that's, that doesn't mess up, doesn't mix up all the code. It makes it hard to kind of, separate this from that. It allows you to build these different variants or different versions of our app, such as a free versus a paid one. But it also allows you to build what are called build types. So you can have a debug version of the app just for testing, and maybe in the debug version you want to have all the features exposed, the free and the paid ones, just so you can debug them, you can test them, you can maybe send the debug version to your testers, and then you want to have a main version that's the one that your users are actually going to receive on their phone. So it also allows you to do that specification there. And the third one that I think I might have forgot to mention, so I'll mention it now, is dependency management. So let's say you want to add a bunch of libraries, like other code that's been written by other people, and that code is it's like a shortcut to do some design pattern, or to maybe have an image picker or an image loader. Really, a library is just code that's been written by someone else, and it'll be a shortcut to just import that into your project, so you don't have to reinvent the wheel there. So in Android, the way we add libraries is also from within that Gradle file. So it's a file that's provided. The extension is .gradle, and we provide the dependencies, which are all the external libraries that we're going to be using in our app, right into this Gradle file. And the next thing up is XML. So we talked about Kotlin, and we said that Kotlin is the main way of writing your Android application, but we need kind of a separate way to write out our layouts, to actually design our components that are going in our application. And XML is the way that we do that. So in fact, now there's a more modern way. I'm just going to touch on it very quickly. There's something called composable UI, where you can actually start writing your UI using Kotlin code. And just from the experience of people who've been working with Android for a long time, that actually is a way that it seems like that would be the first way to do it. Like, you would imagine that building your UI right from the same place that you're writing your business logic code is the way they should have started. But for some reason, they've separated the UI parts, or the UI building, into XML. I think this just comes from like the web tradition, where you have JavaScript to do all the business logic, and you have HTML to display all your components. So in Android, they kind of adopted the same system. So you have Java and now Kotlin to do all your business logic, and you have XML to be building out your user interface. But once again, there's something called composable UI, and you can start composing your user interface using Kotlin code, and it has a lot of advantages. It was actually only recently added to the Android SDK, or software development kit. Now I have a number of examples here of some of the components that we can use to build our layout, our XML layout. One of them, so first off, worth mentioning that whenever you build a layout, you have view groups and views. So a view group is a group of views. That's why it's called view group. And it can house within it a number of like subcomponents called views. So everything that you see on your screen here, the linear layout, a relative layout, and a constraint layout, and there's a bunch of others too, these are view groups. They allow you to group different views together. The most simple, the most basic one is a linear layout. I have an example of it here on the right. It essentially just stacks views either horizontally or vertically. So if you use that specific type of view group, you know that your views are going to be stacked in a way that you would expect. So this could be like, maybe you want to have, let's say, a profile. Let's say you're building a profile section of your social network, or of your chat app, and you want to have things stacked one on top of the other. So maybe you want to have a profile picture, then first name, then maybe email address, but you want to have them all like just one on top of the other. So a very simple way to do that would be to put them right within a vertical linear layout. And of course, you can also in other cases use a horizontal linear layout, and they would be stacked horizontally. All right, now that we've covered the main components, the main 4 components of Android, and we also touched on some of the other kind of parts of Android. In fact, there is one more thing that I don't have in my slides here, and we're going to be seeing it in Android Studio, and it's called the Android manifest. That's just one file, and the manifest, it's like the plan of your app. It contains all the different activities, all the different services, all the different content providers. It's like an index. So whenever you add that code into your app, it's not enough to just have that code there. You have to go into the manifest and say, hey, I'm going to be using the following activities. And if you try to launch an activity that's not in the manifest, you're going to get a crash. And in the crash, it's literally going to say could not find this activity in the manifest. Did you forget to put it there? So, that's a strong hint. Just go back to the manifest and declare your activity, because the manifest is like the blueprint. It tells your app what needs to be there so that you don't have anything in your app that it's not expected to be there. So that was kind of one other thing, one other honorable mention that I probably should have had a slide for, but we will see an example of that in Android Studio. So before we get into Android Studio, before launching it, let's talk about what it is. So Android Studio is the perfect tool to build Android applications. It was developed by JetBrains. That's the same company that we mentioned earlier, the same company that created Kotlin. And Android Studio is what's called an IDE, or an integrated development environment. It gives you all the tools you need to build and ship your Android application. It's, as I mentioned, it's developed by JetBrains. It runs on Mac, Windows, Linux, and Chrome, and it's free. In fact, anybody can download it. I've already went ahead and I went to that website and I downloaded it already for my Mac ahead of this session, just to save us some time. But of course, for your side, you can go to that link and just download it. Or if the link is not clear, you can always go on Google, just type Android Studio. I'm sure the first result will take you there. And what I'm going to do now is I'm going to switch over to Android Studio so we can get familiar with it and be prepared for the next session where we're actually going to start using some of the concepts that we described today.
Android Studio makes my laptop die. So beautiful.
There's memes about that. Like there's people people doing a barbecue on their computer, and it's running Android Studio. Cool. So I think now you should be able to see Android Studio on my screen.
Yeah.
So this is the welcome screen. That's the first thing you see the first time you run Android Studio. So as you can see on the left, there's like the recent projects. I've already created one ahead of time, which is my application. But instead of launching it, I'm just going to show you how I created it, so you get an idea of how to get started, how to build your own very first project. So very simple. We click on Create New Project. And it gives you a bunch of templates. It says, so how do you want to start this? Do you want to have like no activity? We talked about what an activity is. It's basically a screen. Maybe you want to, use activities that you've written in other projects. So you might not need to have it included or use the template. You can have a basic activity, which is actually the one that we have in the example that we're going to be demonstrating. You can have a bottom navigation activity where the navigation is on the bottom, much like I think how Facebook works. You have icons on the bottom of the screen. You can have a fully empty one. You can have a maps one. There's a whole bunch of different activities out of the box that just make your starter code more geared towards the task that you want to build. So what I've done for the example that we're going to demonstrate is I've selected basic activity. As you can see, it's got it's got like 3 dots in the top right. This is like a menu. It's got a back button. And it's got what's called a floating action button, which is like the little plus icon here. And we're going to see this in action and talk a little bit about some of these parts. If you hit next, it's going to ask you for a name of your application. So it could be, my next great chat app, or, if you can have whatever name that you come up with. This is completely entirely up to you. The next thing you want to specify is a package name. A package name traditionally is the reverse of your domain name followed by your application name. So I'm Adam. So maybe I don't have the domain adam.com, but if I did, I would type in here com.adam, which is the opposite of adam.com. And then I would follow it by the name of the application. And then it asks you, where do you want to save it? So, you don't lose it, you know exactly where it is and you can access it later. And of course, it suggests that you use Kotlin, but you can fall back to Java if you want to go back to prehistoric times. And the final thing is it asks you for a minimum SDK. So an SDK is, it's short for software development kit, but really what it's saying here is what version of Android, what is the minimum version of Android that you want to support? So if you want to support like a large number of devices, even the older ones, you might want to select like an older version of Android. So API 16, if you pick API 16, Google already has a statistic for you here. And it says, if you go for API 16, your app will run on almost 100%, like 99.8% of the devices that exist in the world today. But for example, if we go to Android 30, the number like goes, well, I think Android 30 hasn't even shipped yet. So that's why it's less than 1%. But for example, if we go to Android, API 29, it's a fairly modern version of Android. And not everybody has their phones up to date. Not everybody is buying a brand new phone every day. Only about 8% of Android users have that latest version of Android. So you want to be mindful of that. You want to keep in mind what version of Android that you want to support, because newer versions obviously have more features, but the downside of that is that they're not compatible with older phones that may have not been updated yet. So if I hit finish, literally it's going to create my application, and it takes a few minutes to kind of load it up. So instead of just hitting finish and let that happen, and to save on time, I've already created my application. But this will, if you hit finish, that's exactly, don't worry about this. That's exactly what you're going to be getting. This window right here, it's going to do a bunch of syncing. It's just going to be fetching some data from the it's going to look at Gradle. It's going to be like, okay, I need some dependencies. I need to build my application a certain way. And then finally, when all the processing is done, you're going to have this window in front of you, and it's going to look like that. And let's kind of break it down into the different parts. So on the left-hand side, this is your project pane, right? And you can open it and close it just by clicking on project here. It shows you all your files. And right now we've selected Android from this top drop-down menu, means show me the Android files, right? You can also show all files if you just go select project. So that now it's going to work more just like an explorer, like a file explorer. But because Android Studio is smart enough to understand that this is an Android project, it will show you only the files that you might be interested in as an Android developer. So I've went ahead and done that, and I basically selected Android, but it was the default option. It just shows you the files in the Android way. Now you're going to see a bunch of folders here. There's the manifests. So we talked about what the manifest is. So right now, if you look into the manifest, also the manifest, by the way, is written in XML. So it's there's XML being reused for both the layouts and also for manifests. If we just quickly skim over it, we'll see that it's kind of like a hierarchy. So first we have our application. So this is our entire application, and within it we can have activities, we can have services, we can have content providers, we can have broadcast receivers, and in our case we just have this one single activity, and you can kind of guess what each of these parameters is. Like this one is name, so that's just the name of the activity. Label, that's what it's going to say when you launch that activity. For now it just says my application. Theme, that's the theme of your application. You can specify which colors, maybe a primary color, secondary color, and you can do that. You can specify a theme right from here. There's also this block here, and it says intent filter. So I'll go into that maybe next session, but for now you need to know that the main activity, the one that's going to be launched first when you launch your application, needs to have this block. It basically has two kind of let's call them sub elements. One of them is action.main, and the other one is category.launcher. This dictates that this activity is the launcher activity. It's also the main activity of your app, so that Android knows the first thing to do when anybody launches your application is to launch this main activity. Also keep in mind that there's some very cool shortcuts. There's a lot of them. I'm just going to go over one of them right now. If you hit the command button on Mac or control on Windows, and then you click on a class. So this is actually a class. We talked about how an activity is, at the end of the day, it's a component, but it's also a class. So if I command click on it on Mac or control click on it, it's just going to go straight to the class. So I don't have to. I can also, of course, come here, go into the next folder, which we're going to talk about next. So now it says Java. You might be wondering, wow, Adam, you've been talking about Kotlin this whole time, and now it says Java. Thanks for wasting our time. Well, actually, this has Kotlin code, but it's just kind of from the legacy days of Java that it says Java. But as you can, if you look into it, you're going to find that each one of these classes is actually a Kotlin class. So don't worry about it. It's definitely Kotlin, not Java. But it's just the tradition that's been passed on from the Java days. Cool. So within our Java, which should be Kotlin, but never mind. We have 3 classes. We have 2 fragments. We have a main activity. So I'm just going to go right into the main activity for now. We don't have to go over the full details of it now. We're definitely going to be digging more into that in the next session. But I'm just going to collapse some of these methods just to show you that an activity doesn't really have to be that complicated. It just has, so there's a bunch of, these are called like life cycle methods. And a life cycle method is basically something like a method that's called by the operating system whenever a certain life cycle event happens. So if this is complicated, don't worry about it. For now, you should know that the things that you want in the onCreate, which is one of the lifecycle methods, are the things that you want to happen whenever your activity is created. So as soon as your activity is created, maybe you want to do a bunch of things. Like the first thing that you want to do is you want to draw everything on the screen. So we do that here using this line, set content view. That basically means set the view to, or set the content view to a certain layout. And we have this is our first XML here. We talked about how XML is used to build layouts. So if I hit Command and I click on it, it's actually going to take us to the XML of that. And there's a way to basically show you what that would look like if you just go click on design here. But once again, we're going to kind of go into the intricacies of that in the next session. But I just wanted to show you that we have our Kotlin code, we have our XML code, and together they come together and they make the entirety of your application. There's a bunch of other stuff here happening, very simple stuff. This is how you decide what goes in the options menu, and here you decide what happens when you click on some of this things in the options menu. But I don't really want to dig too much into these details. I just want to kind of get you familiar with Android Studio and the structure of it. So we talked about this pane here, that's the project pane. We talked about the pane on the right side, which is where all your classes will live. Of course, you can open multiple classes, they're going to live in different tabs. So this is a fragment. You'll see that because a fragment is almost like a sub activity, there's going to be a lot of similar methods. So we have onCreate in activity. We actually also have an onCreate in fragment, but we would really rather use onCreate view because a fragment is mostly designed for views. So whenever a view is ready, that's where we want to do whatever we want to do. So we use this onCreate view method instead. But instead of boring you with all this technical stuff, so this activity, just by looking here, I guess you can't see my mouse, or can you? Regardless, I'm just going to use.
We can.
Oh, awesome, cool. So we have 2 fragments and we have just the one activity. So we can guess here that we're going to have 2 kind of modular views and 1 activity to house these 2 views, because that's all we can see here. What I'm going to do is I'm going to launch the Android emulator. The Android emulator is like an Android virtual device that lives on your computer that you can launch, and then you can do all kinds of testing. And all these buttons up here, so this is looks like a play button. I've already set up an Android emulator device for myself, and you can do that for you as well by going to into the AVD manager, like the Android virtual device manager. I've already created a Pixel 3a virtual device. What I'm going to do is I'm going to go ahead and launch it. I think it's actually already launched, so it's going to tell me, hey, it's already launched. So it's over here. Let me actually switch to my full screen so that you can see both Android Studio and the emulator. So now you should be able to see both of them.
And I see myself. That's so weird.
Well,
I'll turn off my camera. Okay, there you go.
Awesome. So I'm going to hit the play button and it's going to essentially play or run this activity on our emulator. And because this is the activity that ships with Android Studio, we don't expect any errors, hopefully. And bam, there it is. It's on our screen. It's very much like the template that we saw earlier. We have a bunch of buttons here, but they probably don't do anything useful. So if I click next, look at that. It takes me to another screen that says previous. So what happens if I click previous? uh-oh, it takes me back to the previous screen. Well, that you probably want your app to do a little bit more than just going from one screen to another, but this is just kind of like the starter code that you have that you can start working with. And of course, you can customize it to do all kinds of different things. We also have what's called a floating action button. It's this button right here. If I click on it, it just says replace with your own action. This is like a message. It's just giving you a hint that for now, this button is not doing anything. It's telling you, hey, go do your own actions. And finally, there's the options menu button. We touched on that a little bit. For now, it probably doesn't do anything. It just, if I click on it, nothing happens. But of course, you can specify what happens whenever we go into or choose one of these options. This is we talked about the classes, the main classes of an Android application, which are an activity and some fragments. There's a bunch of other folders, like for example, there's 2 test folders that ship, with your Android app, with your first Android app. This is to do some code testing. We're probably not going to go into it. Not that it's an advanced topic or anything, but it's essentially code that tests your code to make sure that you can identify bugs or you can identify issues. Let me just switch back to just Android Studio. So you can identify issues within your code by essentially writing test code, and that would live here or it would live here. So just if you go to the test directory, that's testing of like business logic code, but you can also test your user interface. Let's say you want your app to look like a certain screenshot. So you can provide it with a reference, and then when you're done building your app, if you somehow accidentally broke it and it doesn't look like the reference anymore, it's going to be like, hey, you did something inconsistent that you asked me to check against the screenshot and they don't match. So go back and fix your code. So that's what testing is for. There's also some generated directories. You don't need to go there like ever. This is just code that's generated by Android Studio, like this generated Java code. And there's also this resource directory and the generated version of it as well. So in resources, that's where all our XMLs live, but also what are called drawables. And the drawable, they can be icons, they could be other XMLs. Like this is an XML that basically draws an icon. And the activity layout, for example, the one that we saw earlier, it's an XML. We talked about that, and you can switch between code and design, or even do like kind of a split screen by picking one of these 3 options. But this is where all your layouts will live. And the next one up is the menu. So this is where we saw the options menu, the one that we were clicking on. Right now, it just has the one settings option, but this is where menus would generally live. And this is like the menu that ships with Android. Obviously, you can have all kinds of different menus or all kinds of different UI, but these are kind of just given to you out of the box, and there's no reason not to leverage them. There's a bunch of other stuff here. So there's like bitmap. So that's basically like any pictures. So now we have the launcher icon. So our application ships with this little Android as a launcher icon. That's what you're going to see after you install your app. It's going to have this little picture, and when you click on it, or when you tap on it, I should say, then your app would launch. And you can provide different versions of it for different devices. So maybe a small version for smaller devices, a big version for like tablet devices. And we'll talk about that a little bit more in the next session as well. There's also like a nav graph. We'll cover that next time. You can just basically here say what happens, between, to go from one screen to another. And the final thing that I want to show you guys before we wrap this up and get ready for some questions is the build.gradle file. So you'll actually notice that there's 2 build.gradle files. There's like a top level one that's like at the root of your directory. We don't have to go there for now, but there's another one, which is this one is like the app version of your Gradle file. So I'm just gonna like minimize all the stuff that that we can dig into maybe later. For now, so Gradle is written in a language called Groovy. Now, it's very similar to Java, actually. It's literally just like most of the things that you're going to need are dependencies. And here, all the dependencies live in this little block here, which is called dependencies. And these are all the different libraries that we've added. So we wanted to add an implementation of the Kotlin library. We also wanted to add some Android stuff. We want to add some unit testing stuff. This ships with your app, but you can, of course, obviously add your own like implementation and then just type the name of the library. And the way to do that would be to go to the website of the library, get its name, and then you would write the name of the library followed by the version of the library. Like, for example, some of the Android libraries here, you can see the name of the package, then the name of the sub package, and finally the version that you want to fetch. This way you can make sure that you're always, whenever you build your app, you're always shipping the exact version of the dependency, so that you don't accidentally ship a newer version that may not be backwards compatible. It's always going to have the same version of your dependencies. And as we talked about, dependencies are really just outside libraries. And the final thing in the Gradle file that I want to go over is, just going to compress this and expand that. We talked about build types. So you can have a release and also a debug version. All you would have to do is just kind of copy this and then just call this debug. And you can have like different configurations for these two. But really, if we're just starting out, you don't really have to mess around with this stuff. All you would likely have to do is just maybe add some dependencies for some fancy libraries that can do some of the neat stuff that's written by other developers. So that's all the time that we have for this session. We went over some Android concepts, some Kotlin code, and we launched our Android Studio. Don't worry if some of this seems kind of like new to you. I promise, with a little bit of practice, you will be on top of it. And it's actually like everything is kind of written very well, and there's many years of experience behind the software that you're looking at here. So I'm sure that just once you kind of get familiar with it, it's going to be a lot easier to work with. Let me switch back to the slides so we can kind of wrap this up. All right, so in the next session, we're going to be building a chat app using Android and Firestore. Firestore is what's called a real-time database, and Firestore essentially allows us to have a database that lives in the cloud, and it's also synchronized to our app. So we don't have to like create our own backend. We don't even have to create our own local database. They're all synced together. So it's very simple to create, to bundle Firestore within your app, and then your data lives on the cloud immediately. And we're going to be combining Android and Firestore to create our very own chat application. So that's all the time that we have for today. Thank you all for attending this session. If you have any questions, I'm happy to answer them now. This is my email here. You can always reach out to me as well. And I hope to see you all in the next session. So let's open it up for some questions.
Actually, can I start off?
Yes, of course.
Fragments are a little bit blurry to me. So for example, what fragments would we create for the chat app?
So for example, let's say you have a chat list and then a chat view. So maybe the first screen would house the full list of chats, like for example, WhatsApp or Facebook Messenger. You would see a list of messages. And then if you click on one of them, it will take you to the detail of that view. So if you want to have two versions of your app, one of them that lives on the phone and then another one that lives on a tablet. And maybe on the tablet version, you want to have on the left-hand side, on the left pane, a list of messages. And then on the right side, you want to see the details of the messages. So you don't necessarily have to, create two versions of your app. You can just create a fragment for the list, another fragment for the detail, and then only view the list or one at a time in the phone version and combine them in the tablet version.
Okay, makes sense. Okay, thank you.
No problem.
If anyone has questions, feel free to unmute or in the chat as well.
Yeah. For some reason, I think because I'm presenting, I can't see the chat. So Lila, please, if you see anything on the chat, if you can just read it out to me.
Yeah, sure.
Yeah.
There's no questions. Someone says no questions, but thanks, Adam. It's been a good talk.
Thank you guys for attending, and I hope to see you all next Thursday for building a chat app with Android and Kotlin.
It's a follow along, right? So we'd be kind of following along with you. Yes,
that's actually a good question. Yes, feel free to follow along. Obviously, these sessions will be recorded, so you can follow along after. Well, actually, So I will be pasting code just to, for the sake of saving some time, but I will also allow you to be pasting the code as well. So I'll provide you with an online copy so you kind of can follow along. But if you find it, too overwhelming and maybe you want to just focus on the presentation, you can always watch the recording later and kind of do it at your own time.
What should we prep beforehand? A question in the chat.
Really, if you just show up with your computer. So if you want to follow along, obviously, I would recommend downloading Android Studio. That will take a little bit of time, maybe 10 minutes or something. So that's actually a really good question. Yeah, I probably should have mentioned that. So if you want to follow along in the next session, make sure to download Android Studio. So I'll provide Laila with a copy of these slides so that you can always go into the Android Studio page and find the Android Studio download page. Download it on your computer, give it its time. It's going to take maybe 10 minutes or something. And once it's done, then you should have everything you need to follow along.
If no one else has questions, I'll give it another 30 seconds. We can finish this up. Thank you guys for coming, by the way. Hope you enjoyed it. And I'll be posting the recording on the YouTube channel, and then I'll send you guys the link through email. Thanks a lot.
Awesome. Thank you guys for attending this session, and thank you, Laila, for having me today. Definitely looking forward to next week. So yeah, make sure to download Android Studio. Thanks for whoever asked that, and I'll see you guys in the next session.
Have a good night, everyone. Bye-bye.
Bye.